the HIKE project. Now I would like to have the bridge to the GeoConnect project. The subsurface is a technologically and scientifically complex and challenging domain, even for geoscientists. Information can be hard to comprehend for people who do not have the background in geology. But did you know that the same faults that we have presented in the last presentation can actually help to make the subsurface better understandable to everyone? And Renata Barros from the Geological Survey of Belgium, GSB, and the project lead of GeoConnect3d is going to explain what solutions she and her team have developed to communicate the fascinating world of geoenergy, groundwater and raw material resources to policymakers and society. Renata, the floor is yours.
Thank you very much, Serge. So Hotlime and Muse showed earlier ways the subsurface can be used to source clean energy, and many other GeoERA projects presented earlier this week and to be presented tomorrow deal with other uses, for example, to source groundwater, raw materials, and so on. And some of these are represented there in this scheme. But all of these different uses certainly call for good management of the subsurface. We cannot talk about making decisions about the subsurface if we don't know well what it is made of. And the good news to us geologists is that we know very well the subsurface is ruled by geology. But the bad news is that it can be extremely complicated, as we know very well, especially in this case where we mostly don't have access or direct access to see what's going on. So it is a big challenge to present geological information about the subsurface. Next slide, please. GeoConnect3d is tackling this challenge by presenting geological data in an innovative way, more meaningful and intuitive to the users. Traditional ways to present geology, such as this geological map of Europe you see there, they are not at all easy to grasp. Although they bring a lot of information, their use is really restricted to the experts. But the GeoConnect3d structural framework aims to gather information like this and many other maps or models in a unique harmonized model, but understandable by anyone interested in subsurface management, geologist or not. So our model is primarily focused on surfaces with geological importance. And these can be, for example, present plate boundaries, such as the one separating the Eurasian and North American plate. They can also be past plate boundaries, separating different terrains in Europe, for example. And we can also think of other surfaces such as deformation fronts, the ones formed after the collision of such terrains in the past and defining different origins. For example, the Caledonian that you see over there. And also faults, they're in red, extremely important surfaces with all the associated potential and also risks, as Serge just presented what is being handled by HIKE. So the structural framework limits are then used to define the relevant geological blocks or units between them, and we can keep drawing these limits all throughout Europe. Next slide, please. And this is a multi-scale model. If you click once, please, we can see that it goes from these very large-scale limits, but to more and more detailed geological information that the user can discover in an interactive way, zooming in and out. And all of these limits and units present in the model, they are concepts that are explained in the project vocabulary, which will be accessible with only one click. And if we go again, the model can also provide context to existing data and models, using specific limits to link surface and subsurface, and helping to make them more understandable to the user. In this example, you can see how the structural framework can provide context to the 3D model from the Flemish part of the Ruhr Valley Graben. And if you click one more time, we see that a specific fault is used to do that link. So this way, the structural framework can take the users through a geological journey that improves their understanding of local features by contextualizing and connecting information at surface and below. And this model will be available for free consultation in use in the GeoERA information platform. And we're also looking forward to incorporating results from other GeoERA projects into it. For example, the models from 3D GeoEU that Stefan will present next. Thank you very much.